Well, we're like, oh, hey, here's some mistletoe. Ah! So this is Job Kite has recently done a revision of Phoradendron, and these are Phoradendron. It's really abundant in the tropics.
I'm not supposed to touch this.
Why?
This is a alert species in the UK.
I'll bet it is.
Yeah.
Because if this spread into the UK, it would spread.
Yeah.
Because it really loves all the other non-native oaks around here.
You know, if I was caught with this in my luggage.
Oh, really? But it's male and female, so maybe this is a male, and there's
no. Just the sight of it is enough.
But you see these buds form in the axils, and you get the buds, and you never know whether it's just going to be vegetative or fruiting, and it's a real simplistic. But this you notice the hair on there, so this is villosum, but Job Kite recently lumped this back with serotinum, which is our eastern mistletoe, and so we're all aghast that the mistletoes have been lumped. But
one of the problems with this mistletoe is its ability to fracture.
Yeah, but we don't know if that means that it can. I don't know if that's
whether the fragments are still viable.
Exactly.
Isn't that the matter? Yeah.
Exactly, and our theory is that the seed has to land on a branchlet which has reasonably thin bark on this tree species.
Does it have the same viscous seed as the European one?
Yeah.
So it wedges into there and then it absorbs the water and actually binds itself even more firmly into the thing.
It cements itself to the, and then you get the germination and Clyde Calvin, do you know him at all? He's from Portland State. He did a lot of the original work on the seed germination and penetration and all of that of this species. But that's pretty much all that's been published. There's nothing else really. So we're doing some work on the ecology of this, trying to determine whether there's an increase in wildlife use in a stand like this with mistletoe then compared to a stand without any mistletoe.
And we found that with the European, it's the birds, particularly the thrushes, and they get the seed stuck and they wipe the bill.
Oh, they wipe the bill.
And they leave the seed behind. Because it sticks there and it irritates them, they wipe the seed onto the branch.
So we're trying, we believe bluebirds, possibly pigeons, our band-tailed pigeon, jays, thrushes, solitaire, and then starlings. And the starlings, of course, are new.
The biggest ones we have are
So this tree has fallen down, and we're going to investigate why this tree might have fallen down. When we look at the butt of this tree, we see that it fell over with no roots. And there's this really white, spongy rot here, which is just rips apart. And this tree had nothing. This is all just white, spongy rot. So this tree had a root disease fungus, and this fungus is common throughout temperate northern hemisphere. Is that correct? Is it in Russia also? Or? Yeah, it's around. And this, we believe, is caused by this, we found this brown conch at the base of the tree, and this is where the pores were. In the pore surface, it's cracked, very blocky. And this is an annual conch that probably formed in the fall, and this is the bleeding conch, Inonotus dryadeus. And we have David Rose here from the UK who's done a lot of work with this in the UK. Can you tell us a little bit about this fungus and how this...
Because when it's young, it's very easy to recognize because it looks like a natural sponge with the water droplets coming out of the holes. So it's very easy to identify that. As it gets older, it changes. It becomes a sort of mealy coloured upper surface with lumps and tubercles all over it. So it's very rough, lumpy.
Right.
Then when it gets ancient like this, it blackens. It looks like a bit of old slag iron from the bottom of a blast furnace.
Right.
But if you turn it over, you'll see the pore surface. And the pore surface is not completely solid and smooth. It is beginning to break up. When it cracks, particularly in the drier ones, it breaks into blocks. And that's one way you can tell it's an Inonotus. All the Inonotus, Hispidus does it on ash, breaks into blocks. Dryadeus does it. Dryadeus does it. They all break into blocks like this. Whereas if you found something, a Ganoderma, that can look rather similar when you look at it like that.
Yeah.
You flip it over, Ganoderma never breaks into blocks.
Right.
So that's a quick way of doing it. The other thing, of course, is the thickness of the tubes. When you look at the tubes, they're very thick here.
Very thick, yeah.
And they are single layer.
Right. Single layer, no second layer. And this conch is only alive for 3 or 4 months, maybe?
That's right.
Yeah.
And so they start to decay. But it is a confusing one because it looks so different from its early stage to the later stage to the dead stage. And most books will show you the classic early stage.
Exactly, because
You
it's
might
so
get a
easy
few
to
showing
identify.
it flattening out into what you over here call conchs, or we call consoles, or
Right.
brackets. But they never show you the dead state,
Which is more
of a
common.
fungus. And you know, I think it's quite important that you do talk about what the dead state is, because with annuals that's important because you always find the dead state.
And we'll see grass and vegetation growing through. It'll grow around
Yep.
some of the vegetation. Now, you were saying the relationship with rot. If you see a conch, is there any way you can estimate how much rot is in a tree?
No, it used to be said the more fruit bodies you saw, or conchs you saw around the base of the tree, the greater the amount of decay. The limited amount of work that's been done on that has shown that to be absolutely false.
Whoa.
Now, the reason you do need decay, first of all, if you do see a fruit body, a conch at the base of a tree, you know there's decay, and you know there's significant decay. What you can't say is the extent of that decay. Fruit bodies are produced through two reasons. One is there is adequate decay to provide this food source, because producing these things is extremely energy expensive. for the
Did you
fungus.
hear the acorn woodpecker? That was the acorn.
That was
So there has to be significant decay for it to be produced. However, the fungus is only provoked into producing the fruit body, generally and initially, by the fact that it's no longer colonizing the wood and decaying the wood. It's able to switch then the reserves it has built up into producing this very expensive fruit body. And if you think about it, it's ecologically significant to do that, because if it's been brought to a halt in the tree and can no longer continue to decay that tree, then its days are numbered. Mycelium will gradually decline. It cannot continue. The only way it can continue is to reproduce and produce its reproductive organ. So that goes out. It may then follow that the tree is then able to colonize even more of, the fungus is able to colonize more of the tree, create more decay, and then you get continued fruit bodies coming out. But it's very difficult to be able to say 100% if you see lots of fruit bodies, there's lots of decay. A typical one for that is the one that causes serious root decay and of beech trees, Vegas, which is Marivellus giganteus, which is very common in Europe. And that is a bad news on beech trees. But one of the problems is we cannot say how significant the decay is in the roots. One, you can't get down there to find out, and two, the appearance of the fruit bodies doesn't guarantee how much decay there is. So we've seen trees fall over with absolutely no other outward signs apart from a fruit body around the base, and we've seen other trees with completely ringed with the fruit bodies that have stood for decades.
So how does it spread primarily? Is it primarily a spore dispersal on wounds, or is it primarily below ground root to root?
This is below ground wound.
Below ground wound?
Yes. This is not above ground wound. And in fact, although you see the fruit bodies being produced above the root collar, on the side of the tree like this, they're coming out through fissures in the wood. And this fungus does not take the sapwood typically.
All right.
But because it dries out the wood inside and the decay causes differential fruiting into the wood, you get cracks in the sapwood. And through those cracks, the mycelium will come out and the fruit body will form. And with Inonotus, as with an allied group called Finlinus,
Yeah.
you get a mycelial plug,
Yeah.
yellowish. And that forms, and the fruit body forms on the basis of that. So if you took that one off really close to where its attachment, you'd see that yellow mycelial things. And now in some of them, the mycelial plug is like a ball, and it's very obvious. In Inonotus and Finlinus, it's not. It's just an area of increased mycelial formation, very concentrated, and it's yellowish. You can find it quite easily.
Yeah, I've seen that with Finlinus pini on Douglas fir.
Yeah.
Well, that's very nice of you. Thank you, David, for that course on Inonotus dryadeus, a root rot of Oregon white oak, and also famous throughout the world.